All right, everybody, so this video is on piecewise functions. I think you'll actually find piecewise functions are not too bad. Please make sure you have the date right up here, please, in this corner. And at some point, there might be another naming for this, this video, so you could look here. I haven't come up with a title for this video, but you might have some sort of, unit 4 or something like that, So just FYI, I probably won't edit this video, but make sure your notes line up with this. So when we're talking about piecewise functions, it's pretty straightforward. All you do is go down to your exercise, right? Your first one, which is this guy. And I'm simply going to color code F in red, and I'm going to color code G in green. Does that make sense? And then within each of these, I'm going to have a couple different colors. I'm going to have a couple options. I'm going to have a black dot. I'm going to have a green dot. And then I'm going to have a black dot here, a green dot, and I need another color, so I guess I'll make it purple, because that's one of my colors that I got here. And that's that. Okay, so just be aware of those colors, and I'll explain what they mean in a second. It's pretty simple. Look at the letter on number 1. Does that, if the letter on number 1, sorry, I'm going to change these to blue because I already used green. The letter on number 1 is F or G? F. So are you going to use the red top function or the green bottom function? Top function. Okay, cool. So I'm going to circle this in. I'm going to put a red like here to show that we're going into this function. Okay. Now the number inside is 0. Do you see how it's 0? Well, the question is now, here's the big deal. Okay, watch this. This is what's most important, is to understand that we need to decide if this is true or this is true. Is x less than 1? Or is x greater than 1? Look at the number we're putting in. It's 0, yeah? Is 0 less than 1 or greater than 1? Jump in. What do you think? Less than 1. So are we going to use the black dot or the blue dot? Black dot. So it's pretty straightforward. We're going to use this to put this number in. 2x plus 3, right? And we're going to put in the number 0. So 2 times 0 plus 3. Well, what's 2 times 0? 0? So I'm going to put that underneath. So 2 times 0 plus 3, which is 0 plus 3, and the answer is 3. And that's it. Okay? So I'm using colors to coordinate everything. It's pretty simple. Look at number 2 and tell me whether I'll be going into the green function or the red function. So somebody raise their hand and tell me whether I'm going into the green, G, or the red, F. Tyler? Yeah, the function f, because there's a letter f here, so I'm going to use the red function, the top one. Totally ignore this at that point. So all you're doing is you can really ignore this once that happens. Whoops. We can really actually, let me just kind of cover it up like this. So I'm going to make a little shape here. We'll fill it in with something, and we'll just like black it out completely. Okay, make sense? So now we know we're just using the red, so I blocked out the whole bottom. Okay, now we have to decide if we're going into the black dot or the blue dot, right? It's pretty simple. The black dot, top part, or the blue dot, the bottom part, because this function changes. It's 2 pieces, right? That's why they call it piecewise. So the x value inside of this thing is 1, yeah? You see how it's 1 right here? So is that going to go into the top? Is that less than or equal to 1, or is that greater than 1? Less than or equal to 1. So we need to use the black dot. So we're going to use 2x plus 3, and it's going to be 2 times 1 plus 3. Well, 2 times 1 is 2, so 2 plus 3 is 5, and that's our answer. Okay? Now look at 3. Why don't you try 3 on your own? So we're going to put that as a now you try. So we'll write now you try here, NYT. So go ahead and pause the video and give that a shot. See if you can come up with the answer. Okay, so hopefully that went well. What you're noticing is that you're using f, so you're using the top function. So again, you can cover this guy up. You don't need that at all. And you're using the bottom part, the blue dot of f. So the answer is going to be negative 20. It's a now you try, so I'm not showing you the process for that, but what you hopefully got was negative 20. So let me show you one more of these. Maybe we'll go to 5 and 6. It wouldn't be bad for you to try 4, but let's talk about 5 and 6. If you look at 5 and you look at 6, which function do I need to use, the red function or the green function? I think we would agree that it's the green function, right? Yes. So I'm going to cover up the red function now because it's not important. And I'm going to look at the green function only. And I know I'm using the green function because I have a g here. So I'm going to plug in 0, and I'm going to ask you, is 0 less than or equal to -3? Is 0 between -3 and 1, or is 0 greater than 1? So jump in. What is it? It's between -3 and 1, right? So we have to use the blue dot of this piece, which is just 2. Correct? So all we have to do is use the blue dot, which is just 2. But if we have just 2 for our function, if our function is just 2, which is the blue dot, then how do we plug 0 into 2? We really can't, right? So that's our answer, 2. The answer is always going to be 2. If you look up the blue dot and you use the blue dot from this function, the answer is always going to be 2. So let's try a couple more. We have g of -3. Are we going to use the red function or the green function? Okay, red function or green function, f or g? G. So we're going to use g so we can cover up f again. Right? That was kind of a waste of time, but I just wanted to show you. We know that that's going to match with green, so colors are really big on this thing. Green means that we're using this guy. -3, where does it fall? Does it fall less than or equal to -3, or between -3 and 1, or is that greater than 1? Well, -3 is less than or equal to -3, so we need to use black dot. So we're going to use this guy right here, x squared, black dot, plus 3. And we're going to put in -3 and square it, and then add 3. So -3 times -3 is 9, plus 3. So 9 plus 3 is 12. So that's our answer to 6. All right. So we're in pretty good shape here. I'd like you to pause the video and try 4. I'd like you to try 4. I'd like you to try 7. And I'd like you to try 9. I'll give you the answers, but I want you to pause the video and try those 3 problems on your own. Decide where you're plugging in, decide what dot you're plugging in for, and take a few minutes to try those problems. So pause the video and give that a shot. All right, so you paused the video and you gave that a shot, and now I'm going to kind of quickly just kind of go over answers for you, just so you know if you got the right or wrong answer, okay? So for the first one, you want to have -5. So the first one, you want to have -5, and I believe that makes sense. So that answer is -5. For number 7, you want to have 6. That's the answer to 7. And for number 9, you want to have, let's see, I think 28 is the answer to number 9. So those are all your answers there. I'm just going to show you one more problem, which is number 8. And I'm going to ask you whether that's a G or an F down there over here. That's a G, right? So we're going to use the green function, which is this guy here, this one, underlined in green. And I'm going to ask you whether I'm going black dot, blue dot, or purple dot. Which piece do I plug into? Yes? Purple dot, because that's greater than 1 or greater than or equal to. So I've got to plug into the purple dot, so I'm going to grab my purple pen here, and I will have now x plus 5. But what's x? Well, x is 3, so 3 plus 5 is 8. And that's your answer to that problem. So piecewise functions aren't too bad. All we're doing here is we're evaluating piecewise function. We're just plugging stuff in for a piecewise function. All right. Okay, so I'm going to try to quickly just talk about something real fast before we wrap this up. If you look at these problems right here, you might remember how to graph this line right here, y equals -4x. Well, the way you graph that is you go to the center, right? And you go down 4 over 1. So you start at 0 and you go down 4 over 1. Up 4 over 1, right? Now this is like a little bit of an extension, so you might find this to be a little tricky. That's okay. So I graphed that line, do you see? Now what did that line say? That line says if x is less than or equal to 0, right? Is less than or equal to 0 on the left side or the right side of the graph? Is that on the left side or the right side of the graph? the left side. So what I'm going to do is I'm going to erase everything on the right side. Literally going to erase it. Because for all of these, this is x equals 2, this line here. This is x equals 1, so I'm going to erase that. This is x is equal to 0. I'm going to stop at x is equal to 0. So I'm erasing part of the graph. I'm going to make another line, okay? And in the spirit of the holidays here, we got 4. So I want to graph the line y is equal to 4. I want to go on the y to 4, 1, 2, 3, 4 right here and make a line. But I want to ask you, did they say to go for graph 4 when x is greater than 0 or less than 0? When x is greater than 0, right? This might be a bit over your heads, but we'll talk about it still. Greater than 0 is everything on the right side of the graph. So I need to erase everything on the left side of the graph of this line, okay? That didn't really work too well, but that's okay. And also you'll notice there's an open circle here because of this symbol. And there's a closed circle here because of this symbol. And that's what that piecewise function looks like. Yes, it's crazy, but that's kind of how it works, all right? And also the red should not be there. It's not the best because it's messing up my color code system. So we'll just kind of do this. And now you can kind of see what's going on a little bit better. I don't know. Okay, so that's just a little extension. Don't worry about this last example too much. We'll wrap it up there. Peace. Piecewise.